Okay, we're going to take a look at this 31-year-old female who's referred to the pulmonary function lab for shunt study. Her chief complaint is shortness of breath with exertion and at other times. Her referring physician suspected a shunt and requested a shunt study. The subject was in no apparent distress on arrival at the laboratory. She never smoked and had no significant environmental exposure to the respiratory irritants. Her mother died of a stroke at age 50 years, but there is no heart or lung disease in her immediate family. So with the shunt study, they're going to have her breathe 100% oxygen. After 20 minutes of breathing the 100% oxygen, they drew these gases. So here it indicates she was given 100% oxygen. Here's the barometric pressure that we're to use in our calculations. Acid base is actually normal, fairly normal. PaO2 is 557. Bicarb again is normal. Looking down here then, we see her hemoglobin is significantly low. Carboxyhemoglobin, methemoglobin, actually pretty much normal. Okay, so let's start our calculations for our shunt. Remember, the first thing we need to do with the shunt is find our P big AO2. So to do this, we're going to take our barometric pressure, which was 752, and subtract out our water pressure, which we always use 47. Okay. Then we take 38 from our blood gas, our CO2 from our blood gas, divide it by the respiratory quotient of 0.8. You should end up taking 705 minus 48 for a big PaO2 of 657. So now that we have that information, we can go ahead and calculate out our shunt. So plug in our big PaO2 here. So we get 657 minus 557 times our 0.0031, and then we're going to divide that by 4.5 added to our 657 minus 557 times 0.0031. So what I did is I solved this first, okay, and then I solved this, and then moving down here, we end up with 0.31 divided by 4.5 plus 0.31. Work it out even further, you get 0.31 divided by 4.81. Your final answer should be 0.06 or 6%. So she has a 6% shunt. This really isn't too bad. Normal's 2 to 5, so she's within a good range. So why is she so short of breath? We still haven't figured that out, especially with exertion. So let's take a look at our oxygen content of our blood. Sorry, I didn't finish that sentence. So here we're going to take 13.4 times our hemoglobin times our oxygen bound to hemoglobin plus our PaO2 times 0.0031. We get these values from our blood gas results over here. Go ahead and plug them in. 13.4 times 7.4 times 0.996. Add that to your 557 minus, and that should be multiplied by 0.0031. Sorry, that should be multiplied, not minus. Yeah, I made a mistake there. So you're going to end up with 9.9 plus 1.7. and you end up with an oxygen content of 11.6. Normal oxygen content should be about 20 milliliters per deciliter, so this is actually significantly lower than normal. So when we talk about why is she so short of breath, most of us could have easily looked at this and said, well, her hemoglobin's low, that's the problem. But making that assumption without going through the calculations, we could miss something. So we actually just proved to ourselves what we probably already assumed, that her oxygen content in her blood was actually low, and it's due to her having low hemoglobin itself. So when she does any exercise, she doesn't have those cars carrying the oxygen to her tissues, so she ends up getting shortness of breath on exertion. That concludes this case.